Welcome students. In this session we are going to learn about Taylor series expansions. Before that we have to understand what is the expansion of power series, standard power series. We know e power z equal to 1 plus z by 1 factorial plus z square by 2 factorial etc. up to z power n by n factorial. This expansion is valid for mod z less than infinity for all finite value of z. Sin z is z minus z cube by 3 factorial etc. up to minus 1 to the power n plus 1 into z power 2n minus 1 by 2n minus 1 factorial. The sinusoid expansion is also valid for all finite z. Cos z equal to 1 minus z squared by 2 factorial plus z power 4 by 4 factorial etc. up to minus 1 to the power n z power 2n by 2n factorial etc. This also valid in mod z less than infinity. Sin hyperbolic z can be written as e power z. Here you are having the formula of sin hyperbolic z equal to e power z minus e power minus z divided by 2. By making use of this expansion e power z, you can able to get what a sin hyperbolic z is. Likewise, cos hyperbolic z, we can write it as e power z plus e power minus z divided by 2. So from this formula, you can able to get 1 plus z squared by 2 factorial plus z power 4 by 4 factorial etc. up to z power 2n by 2n factorial, where modulus of z is less than infinity. 1 by 1 plus z expansion of it, if you are writing in the numerator, you will get 1 plus 1 plus z power minus 1. By using binomial expansion, you will get 1 minus z plus z square minus z cube etc. up to minus 1 to the power n z power n, where this power series is valid in the range mod z less than 1. Likewise, here you are having plus and the power is minus, so alternative terms are positive and negative, whereas in this you are having 1 minus z whole power minus 1. So this is also minus and power is also minus. Therefore, all the terms are going to be positive. 1 plus z square plus z cube etc. up to z power n, where modulus of z is less than 1. Likewise, you can write down other binomial expansion in this category. Now come to Taylor series statement. A function f of z be analytic at all points inside a circle C with its center at A and radius R, we can expand as f of z equal to f of A plus f dash of A by 1 factorial into z minus A plus f double dash of A by 2 factorial into z minus A the whole square etc. In general, you can write it in this manner. Sum of n equal to 1 to infinity z minus a to the power n by n factorial into fn of a. So here the circle is mod z is equal to a. Now consider this problem. Expand 1 by z minus 2 at z equal to 1 as a Taylor series. So about the point z equal to 1, you have to expand this Taylor series of this function. Taylor series expansion is applicable for finding the function value about the point. So here the point z equal to 1 referring 1 comma 0. Okay. Now you have to find out the derivative of f of z at the point z equal to 1. So first f of z equal to 1 by z minus 2. Find out what is f of 1. It is minus 1. F dash of z is minus 1 by z minus 2 the whole square, which gives you at the point z equal to 1 is minus 1. F double dash of z is 2 by z minus 2 the whole cube. At the point z equal to 1, the value is 2. Like this, if they are not mentioning the degree of the power, then you can stop it with either in degree 3 or degree 4. So here we are finding up to the third degree, like f triple dash of z equal to minus 6 by z minus 2 the whole power 4. At the point z equal to 1, it gives you the value as minus 6. Now substitute in the formula. What is the formula? You are going to have f of z equal to f of 1 plus f dash of 1 by 1 factorial into z minus 1 plus f double dash of 1 by 2 factorial into z minus 2, z minus 1 the whole square, etc. Already we found out the values of f of 1, f dash of 1, double dash of 1 and f triple dash of 1. Substitute all these values in the formula, which gives you minus 1 plus f dash of 1 is minus 1 by 1 factorial into z minus 1 plus f double dash is 2 by 2 factorial into z minus 1 the whole square, and f triple dash of 1 is 6 by, here you are having minus 6 by 3 factorial into z minus 1 the whole cube, etc. By doing the simplification, you will get minus 1 minus z minus 1 plus 2 gets cancelled. You are going to have z minus 1 the whole square, and 3 factorial is going to be, okay, 6. So these two gets cancelled. You are having minus, here you will have minus sign, minus z minus 1 the whole cube, etc. Hope you understood how to find out the Taylor series expansion of this problem. Now we'll move on to the second problem. Expand cos z at z equal to 0 is a Taylor series. So here also we have to find out the function value at its derivative. F of z is cos z at the point z equal to 0, it is 1. Here the z equal to 0 point is referring the origin. F dash of z is differentiation of cos z is minus sin z. F dash of 1 is equal to 0. Then f double dash of z is equal to minus cos z. At the point z equal to 0, you are going to have this is 0, this is 0. At the point z equal to 0, you are going to have minus 1. F triple dash of z is z sin z, because cos differentiation is minus sign. So already minus sign is there, plus sin z. At the point z equal to 0, sin 0 is 0. So you are getting f triple dash of 0 is 0. Now substitute in the formula. You are going to have f of z equal to 1 plus, what is the formula if you want to know f of z equal to, that is here about the point f of a, okay, f of a equal to what? F dash of, you will get here, let us write it properly. You can see the formula here. F of z equal to f of a plus f dash of a by 1 factorial into z minus a. So here about the point z equal to 0, you are going to get the formula as f of z equal to f of 0 plus f dash of 0 by 1 factorial into z minus 0 plus f double dash of 0 by 2 factorial into z minus 0 the whole square plus f triple dash of 0 by 3 factorial into z minus 0 the whole cube, etc. Now substituting these found out value at the point z equal to 0, you will get 1 as f of 0 plus f dash of 0 is 0 by 1 factorial into z minus 0. F double dash of 0 is minus 1 by 2 factorial into z minus 0 the whole square. F triple dash of 0 is 0 by 3 factorial into z minus 0 the whole cube, etc. By doing the simplification, you are getting the answer as f of z equal to 1 minus z square by 2 factorial plus z power 4 by 4 factorial, etc. Okay, this is how we need to find out the Taylor series expansion. Here we have the expansion of Taylor series about the point z equal to 0. The other name of this series is Maclaurin series. Okay, if A equal to 0, then Taylor series become Maclaurin series. Now take down this problem. Expand log of 1 plus z as a Taylor series about the point z equal to 0. How to solve this? Here the function f of z is log of 1 plus z. Okay, what is about the point 0? You are going to have log 1 is 0. Then f dash of z is equal to 1 by 1 plus z. So f dash of 0 about the point z equal to 0 is 1 by 1 plus 0, which gives you 1 itself. Likewise, f double dash of z is minus 1 divided by 1 plus z the whole square you will get. So f double dash of 0, you will get it as minus 1 by 1 plus 0 the whole square, which gives you minus 1. Then f triple dash of 0 is, first you have to know what is z. So it will be, if I am writing in the numerator, minus 1 plus z the whole power minus 2. So by doing the differentiation, you will get 2 divided by 1 plus z the whole power minus 3. It is not minus, plus 3. So f triple dash of 0 gives you 2 by putting z equal to 0. Like that it goes off. So what is the uh, formula? Here if you are getting Taylor series about z equal to 0, it is called what? Maclaurin series. So what is the Maclaurin series? Maclaurin series is f of z equal to f of 0 plus f dash of 0 by 1 factorial into z minus 0 plus f double dash of 0 by 2 factorial into z minus 0 the whole square plus f triple dash of 0 by 3 factorial into z minus 0 the whole cube, etc. Now substituting the value here, you will get f of z What is this f of z here? It is log of 1 plus z equal to f of 0 is 0, f dash of 0 is 1 by 1 factorial into z minus 0 is z plus f double dash of 0 is minus 1 into z minus 0 the whole square divided by 2 factorial plus, okay, f triple dash of 0 is 2 divided by 3 factorial into z minus the whole cube, z minus 0 the whole cube, etc. So, the expansion of log of 1 plus z is equal to z by 1 factorial minus z square by 2 factorial is 2, okay, and plus 2 by 6 into z cube, etc. I am stopping here in the third degree. Therefore, this I can do the simplification z minus z square by 2 plus z cube by 3 is a third degree expansion of log of 1 plus z. Hope you all understood. Okay, it's very simple to solve it. To get the solution of log of 1 plus z as a Taylor series about the point z equal to 0. First find out the derivatives, and at the point z equal to 0 you have to find out the derivative values. About the point z equal to 0 referring the Maclaurin series and substitute the values in the formula, you will get the like Maclaurin series, that is Taylor series about the point z equal to 0, you can able to get the value. Thank you all. Hope you understood. We'll see it in the next concept.